So let's move to PV system contribution. There is an allowable PV contribution based on Panelboard Bus Rating and overcurrent protective device sizing. So in this case, going back to our system we started with, we're talking about this PV system, the AC output into this distribution panel board. Is there an allowance? And the answer is yes. There's an allowance for maximum. And we have to, again, we have to remember that bus bars are conductors, and all conductors must be protected at the rated ampacity. The Panelboard Bus Rating determines the main circuit breaker or feeder circuit breaker size. So what I mean by that is if you have a 100 amp Panelboard bus, can you protect that with a 200 amp main circuit breaker? The answer is no. The basic rule is you have to protect all conductors, including bus, at their rated ampacity. Well, what's unique about PV systems is, again, they're not a load, they're supply. So when we interconnect a PV system or an inverter to a panel board, that's a second electrical supply to the panel board. It's like adding another main breaker. So some people think, well, yeah, but if my PV is supplying current, then that means the utility's not, so why does it matter? Well, don't think about who's supplying it, just think about, can I increase a supply to greater than the ampacity of bus bars? And the general answer is no, you can't. Now, there are some special provisions in 690 and 705 that allow us to do so within some limitations. So the NEC does allow you to supply more current than the Panelboard Bus Rating. And why is that? Well, loads on branch circuits can rise, can go up beyond the rating of the bus bars. So what protects those bus bars? And that's either the feeder or the main circuit breaker. Here's a good illustration of that concept. If we have a PV input or an inverter input to an AC distribution panel board, it's an input. It's providing current to these bus bars, along with possibly the utility in this case. The utility, the 100 amp main breaker at the top, PV input, this 20 amp breaker at the bottom, but both of those are supplies. What controls or what limits ampacity on this 100 amp rated bus bar? These overcurrent devices only. Because loads, if you add up all these loads, these 15 and 20 amp branch circuits, they could exceed 100 amps. So that's okay, but it's not okay if the bus bar is only rated for 100 amps. So that's why we have a main breaker or a feeder breaker. But when we introduce a PV system, we now have a second input. So for that reason, there are some very special rules that say you can do this, but there are limitations. You'll find those limitations for load side connections in 705.12. And the basic rule is that the panel board have a bus rating sufficient for the PV contribution. If it's a supply side connection, you have a different set of rules, and basically just if the supply side means you're interconnecting on the supply side of the main breaker. So the main breaker will protect the panel bus, but obviously you can't exceed the rating of the service at that point. So you have a higher limitation, but there is still a limitation for a supply side connected system. But where you're on the load side, and that's what we're concentrating on here, where a panel board is supplied simultaneously on the load side by a primary source of electricity and one or more other power sources, and also capable of supplying multiple branch circuits or feeders. That's a key line. So if it's also capable of supplying multiple branch circuits or feeders, then we have some limitations. And there's basically two that are applicable there. We're leaving out feeder taps and other methods, but for the bus bars themselves, there's what's commonly called the 120% rule of 3B, and something else that I call the limited load rule of 3C. So those are two practical ones for applying to panel boards. We'll go through those now. So for 3B, or the 120% rule, what that says is the sum of the main circuit breaker rating, or the feeder breaker, and 125% of the inverter output are not to exceed 120% of the panel board bus rating. So you're allowed, a 20% extra supply, if you want to think of it that way in this case. There are some limitations. First of all, the PV system circuit breaker must be located at the opposite end of the panel board bus from the utility supply connection. Think of that, and I like Jody's term, it's so that you can soak up that extra current. If you put all the load between the two supplies, What that does is that it allows those loads to draw off the two supplies so that you never end up with too much supply at any one location on the bus bars. And you also have to have a warning sign telling you, hey, don't move this breaker. It needs to stay here. So I made up this chart. Again, common ratings. If you go across the top, panel bus rating, here's some common panel bus ratings: 100 amp, 125, 200, and 225. And if we use the 120% rule, we're allowed a contribution from all sources of 120% of that. So that would mean I can have 120 amps for a 100 amp panel bus from all sources. For a 125, I can have 150 amps. For 200, I can have 240 amps, and for 225, I can have 270. So the next variable is the main circuit breaker or feeder circuit breaker rating. So if I'm allowed 100, and just looking at this first column, if I have 100 amp bus rating, and I'm allowed 120 amps from all sources, and my main circuit breaker is 100, then I'm allowed 20 amps of PV supply. If I had a 125 with a 100 amp main, I'm allowed 50 amps. But if I had a 125 amp panel bus with a 125 amp main, I'm only allowed 25. So there's an interaction between the main circuit breaker rating, the panel bus, and that determines what the permitted PV supply is using the 120% rule. If you look over to 225 amp rated bus bars, you're allowed 270 amps from all sources. So if I have a main circuit breaker of 200, I'm allowed 70. But if I have a 225 with a 225 amp main, I'm allowed 45. So these are some very common ratings. Again, it can help you to build a chart. So if someone's using the 120% rule, these are the numbers you have to work with. Notice one key element is that this is not the PV circuit breaker rating. The code doesn't say this is a circuit breaker rating. This is the actual inverter output at 125%. So cannot exceed this number. Circuit breaker could be larger on the PV side. So putting that math into action with our drawing, if we had a 100 amp panel with a 100 amp main, we're allowed 120 amps from all sources, 100 amps times 120%. What do we actually have? Well, our 18 amp circuit breaker, or I'm sorry, 18 amp continuous output from the inverter means we're under 118, 119 is less than 120, so we're good to go. That would work. Going back to our larger system with two inverters, we have in this case, an input of about 47 amps from both inverters to this bus bar. So is that compliant? Let's see. We have a 225 amp rated bus in this case. It's protected by a 200 amp main breaker from utility. So doing the math, that bottom line, you can start with that. 225 times 120% means we're allowed 270 amps from all sources. You can refer to that previous chart. And we're only supplying about 47 amps from our PV system. We're allowed 70, so we're compliant because we're less than 70 for that PV system.